Welcome back to another video. Today we will use the mathematical induction to prove that 24 divides 2 times 7 raised to the power of n plus 3 times 5 raised to the n minus 5, where n is any positive integer. So we let Pn be this statement: 24 divide 2 times 7 to the n plus 3 times 5 to the n minus 5. And we try to use the mathematical principle to prove this divisibility. So we have to start with the base step. So what is the base step? The base step is the step where the case n is 1. So we have to start with 2 times 7 raised to 1 plus 3 times 5 raised to 1 minus 5. And now we try to calculate so that we can have 2 times 7 minus 3 plus 3 times 5 minus 5, which is 14 plus 15 minus 5. And it turns out to be 29 minus 5, which is 24, which is 1 times 24. That means that 24 is a factor of this one. Okay? So what do we have here? We're going to have 24 divide 2 times 7 raised to 1 plus 3 times 5 raised to the 1 minus 5. So we have proved that P1 is true. Okay? P1 is true. That's what we have. So we have proved the base step. Now let's go to the inductive step. So how can we deal with the inductive step? So we have to assume that P of k is true for any positive integer k. And then we have to show that P of k plus 1 is true. So that's what we have to show. So since we have P of k, which is true, since pk is true, so what do we have? We're going to have 24 divide 2 times 7 to the k plus 3 times 5 to the k minus 5. So that means that we will have an integer q such that 2 times 7 to the k minus 3 times 5 to the k minus 5 equal 24q. Okay? This is by divisibility. And we have to start with P of k plus 1. So we're going to have, so we have to plug in k plus 1 into this k. So we're going to have 2 times 7 to the k plus 1 plus 3 times 5 to the k plus 1 minus 5. Okay, so let's try to have 24 being a factor of this term. So we're going to have, okay, let me think. Right now we're going to have 7 times 2 times 7 to the k, because we have k plus 7 as an exponent, and plus 5 times 3 times 5 to the k minus 5. Okay, so what can we do next? The next thing that I want to do is to try to have 24. So I want to have 10 times 2 times 7 to the k and 10 times 3 times 5 to the k. I want to have this term first. And also this term minus 10 times 5. So we're going to have 10 times 2 times 7 to the k plus 10 times 3 times 5 to the k and minus 10 times 5. So we cannot we cannot just write this down, so we have to write this term in terms of 10. So we're gonna have minus 3 times 2 times 7 to the k. For this term, we're gonna have minus 5 times 3 times 5 to the k. Okay, and then how do we have minus 5 if you have minus 10 times 5? So we're gonna have plus 9 times 5. Okay, so we factorize 10 out of this term. So we're gonna have 10 times 2 times 7 to the k plus 3 times 5 to the k minus 5. And minus this term, okay, 2 times, give me a second, 2 times 7 to the k, okay, 7 to the k, minus 5 times 3 times 5 to the k, plus 9 times 5. And what about this one? This one right here, according to pk, which is true, which is, it's going to be factor of 24. So we're gonna have 10 times 24 q. And then, how can we deal with this? So, how do we have 24 as a factor from here? So what I'm gonna do is to look at minus 2 7k. Okay, this is 2 times 7k. It is obvious that this term is not divisible by 4 because it's 2 times 7 raised to the power, and 7 is a prime. Okay, 7 is a prime, so it's 2 times prime number. So it cannot divisible by 4. So I have to write 27 in terms of 3 times 5 to the k and 24 q. Okay, so I try to do this. So I have to rewrite this equation so that 2 times 7 to the k is a factor. So we're gonna have 24 q minus 3 times 5 to the k plus 5. And plug this term into here, because I try to have 24 q. So what we have right now is 3 times 24 q minus 3 times 5 to the k plus k minus 5 times 3 to the 3 times 5 to the k plus this one 45. In this case, I substitute 2 times 7 to the k, which is 24 q minus 3 times 5 to the k plus 5. Alright, what happened to this one? I will distribute number 3 into this term. I try to distribute and simplify. So we're gonna have 240 q minus 72 q plus 9 times 5 to the k minus 15 and minus 15 times 5 to the k plus 45. Then 24 minus 72, what is this one? It is 168q and minus 6 times 5 to the k. Okay, and this one is minus 15 plus 45. It turns out to be 30. Okay, the term gets smaller. The term gets smaller, and for this one, I think it's going to have a factor of 24. So let's try to factorize 168. It's going to be 8 times 2 times 21, and 21 have number 3. So it turns out to be 24 times 7. Okay, 68 has a factor of 24. Okay, so it's going to be 24 times 7q. Now what about this one? I can factorize number 6, so we're gonna have minus 6 times 5 to the k minus 5. Well, if this term has 4 as a factor, so we can factorize 24 out of this term, and then we could show that P of k plus 1 is true. So what I have to do is to try to claim that this term is divisible by 4. So try to plug in k equals to 1. So we're going to have 5 minus 5, which is 0. And 0 is divisible by 4. Plug in number 2. So we're going to have 20, which is 5 times 4. 5 to the 3 minus 5 is 120. It is 30 times 4. 5 to the 4 minus 5 is 620, which is what number? Give me a second. 5 times 4. Okay. It seems that this term is going to be divisible by 4. So we have to claim, okay? We have to show this conjecture. So I have to add one more paper, and we have to claim that, or show that 4 divide 5 to the n minus 5. So we have to use a mathematical induction. So we have to let Qn be this statement, 4 divide 5 to the n minus 5. And we have to start with base step. Okay? Base step. So what can we do with this? So we're going to have 5 to the 1 minus 5. We're going to have 5 minus 5, which is 0, which is 0 times 4. As you can see, 4 is a factor of 5 to the 1 minus 5. Okay, so therefore, P of 1 is true. So we have proved the basic step, the base step. Let's go to the inductive step. For inductive step, what do we have? So we gotta have to assume that Q of k is true for any positive integer k, and try to show that Q of k plus 1 is true. We want to show this statement. So we have to start with, so since Q of k is true, okay? So we're gonna have 4 divide 5 to the n minus 5. So we're gonna have, let's say, positive integer or integer q, let's say q1, such that 5 to the n minus 5 equal 4q1. So let's start with statement pk plus 1. So we're going to have 5 to the k plus 1 minus 5. And then we're going to have 5 times 5 to the k minus 5. Okay, what can we do with this? Factorize 5. We're going to have 5 times 5k minus 1. And then we're going to have 5 minus k minus 5 plus 4. And distribute number 5. So we're going to have 5 times 4 like this. And 5 to the k minus 5 is 4q1, right? It's going to have, it turns out to be 5 times 4q1 plus 5 times 4. And factorize number 4, it turns out to be 4 times 5q1 plus 5. Okay, so we have shown that this term 5 to the k plus 1 minus 5 is divisible by 4. So 4 divide 5 to the k plus 1 minus 5. Okay, therefore Q of k plus 1 is true. Okay, and hence 4 divide 5 to the n minus 5, okay, for any positive integer n. Okay, now let's go back to here. So if I have to copy this term, so I have shown that this one right here has a factor of 4. Okay, so since 4 divide 5 to the n 5 to the n minus 5, okay, for any positive integer n, so the x is q2, which is an integer, such that 5k minus 5 equal to 4q2. Okay, so this is what we have right here. So what do we have right here? We gotta have 24 times 7q minus 6 times 4q2. So it turns out to be 24 times 7q minus 24q2. Then it turns out to be 24 times 7q minus q2. Okay, great. So we have shown that this term is divisible by 24. Okay, so 24 divide 2 times 7 to the k plus 1 plus 3 times k plus 1 minus 5. Okay, and hence pk plus 1 is true. Okay, since pk plus 1 is true, what do we have? Therefore, we have shown this example. So 24 will divide 2 raised to the power 2 times 7 raised to the n plus 3 times 5 to the n minus 5. Okay, for any positive integer n. Okay, and that's what we have proved. So we have proved that 24 divide 2 times 7 to the n plus 3 times 5 to the n minus 5. Okay, and that's it for this video.